The eccentricity of an ellipse. For an ellipse of the equation of x squared divided by a squared plus y squared divided by b squared equal 1, with a greater than b greater than 0, the eccentricity e is the number e equal to the ratio of c divided by a, where c is the square root of a squared minus b squared, and in the previous lecture, c is just the foci of the ellipse. The eccentricity is in value between 0 and 1. If e is closer to 1, then c is almost equal to a, and the ellipsis is an elongate in shape. But if e is closer to 0, this means that a and b are almost equal to each other, then the ellipse is close to a circle shape. So the eccentricity is measuring how stressed the ellipse is. So for example, in the next equation, we want to find the equation of an ellipse given that the foci is equal to plus or minus 0 plus minus a, and eccentricity is e equal 4/5. Now I can do this using this, we'll see how straight this is. Now because the foci is on the y-axis, okay, this meant that the denominator of y is greater than the denominator of x. So we'll keep that in mind. So e is equal 4/5 equal to c over a. This is the ratio of c over a. It's not necessary is c over a. And we are given that c is equal to 8. Okay. So this telling us that c squared is equal to b squared minus a squared, where c equal a. If c equal a by this ratio, if c equal 8 by this ratio, and we start with the ratio to be simplified to 4, would mean we had been divided by 2, right? And then would mean a here equal 10. This telling us that now that we have a and c, we can solve for b. So then a equal 10, c equal 8. So a squared equal to b squared minus 10 squared. So 64 equal to b squared minus 100. So b squared is equal to 164. So b equal to square root of 164. Now I can write the equation of an ellipse as x squared divided by 10 squared, that's 100, plus y squared divided by b squared, 164, and that equal to 1. Let's take a look at an application. The gravitational attraction caused the planets to move in an elliptical orbit. So this is why we want to learn about ellipses. Around the Sun with the Sun of one focus. This remarkable property was first observed by Johannes Kepler and was later deduced by Isaac Newton from his inverse square of law of gravity. The orbit of the planets have different eccentricity, but most are nearly circular. Like ellipses like parabola have interesting reflection property that lead to a number of practical applications such as reflecting light and sound wave. Say the planet move around the Sun in elliptical orbit with the Sun at one focus. The point in the orbit is with the planet is closest to the Sun. It's called a perihelion, and the point with the farthest is called the aphelion. Okay, so let's say here's the Earth, and it orbiting around the Sun, and the Sun is in one of the focus. Okay, so now we were told that the point in the orbit with the planet is closest to the Sun is called a perihelion, and with farthest called a aphelion. The point are the vertices of the orbit. So these are the vertices. the Earth distance from the Sun is 1,000. So the Earth distance from the Sun is this much at a perihelion. So it's this distance here. Okay, and at the farthest, then it is this distance. And we want to find the equation of the orbit. Place the origin at the center of the orbit and the Sun on the x-axis. Okay, so let's say that we place this into a xy coordinate plane. Okay, so this will telling us that the distance, so this distance from one vertex to the other vertex is called the length of the major axis, and we can use this to figure out A. So the length of the major axis is 2A, or 2A is equal to 147 million plus 153 million, and that total up to 300 million, which means A is equal to 150 million kilometer. Okay, now if you look at this distance here, this is C, right? And if we place it in the focus, C is where the focus is, that where the Sun is. This distance here can be solved by taking A minus 147 million. Okay, so A minus 147, that will give us C. So C equal to 3 million. Okay, now that we have A and we have C, we can solve for B. Well, B squared is equal to A squared minus C squared. That equal to 150 million square minus 3 million square. And that is equal to okay. So then we can come up with the equation x squared divided by A squared, and that is y squared divided by B squared So that is the equation of the orbit of the Earth around the Sun. The Sanctuary Hall in the Capitol building in Washington, D.C. is a whisper chamber. Its dimensions are 46 feet wide and 96 feet long. What is the standard form of the equation of ellipse representing the outline of the room? Okay, so let's say we place the center of the ellipses at the origin. If it is 46 wide and 96 feet long, So it's kind of like this, okay? So this total distance is 96 feet. And this total distance is 46 feet. So if you draw it like this, then the major axis is on the y. So then the major length 2b is equal to 96. So b equal to 48. And the minor is 2a equal 46. So b then equal, so a then equal to 23. So then here's the equation. So 23 squared plus y squared divided by 48 squared equal 1. If two senators stand at the focus on the room can hear each other whisper, how far apart are the senators? Okay, so how far apart are the senators are talking about the distance of the two focus. So in part B, we want to find 2c. So 2c, that is our goal. So c squared is equal to b squared minus a squared. That's 48 squared minus 23 squared. And that is 1,775. So c is the square root of 1,775. And that is 42. So the distance of the two senators, 2c, is equal to 2 times 42. And that's meant 84 feet away from each other.